Welcome, fellow travelers, to a grand cosmic adventure. Today, we embark on a journey that transcends the ordinary, taking us from the highest peaks of human achievement to the deepest mysteries of the universe. Imagine standing on a mountain peak, the world sprawling out beneath you, the air crisp and filled with the promise of discovery. This is where our adventure begins, at the intersection of curiosity and wonder. Prepare to journey into the very heart of matter, exploring the unseen realms where atoms dance and quantum wonders unfold. Picture the delicate dance of leaves in the wind, each movement a testament to the unseen forces at play. As the sun sets over a calm ocean, casting a golden hue over the water, we are reminded of the beauty and complexity of the natural world. From the aerial view of a forest canopy, we see the interconnectedness of life, a web of existence that mirrors the intricate dance of particles at the quantum level. We stand at the precipice of a new age of discovery where the infinitesimally small has the power to reshape our understanding of the universe and our place within it. Imagine a vast desert landscape, seemingly barren yet teeming with hidden life, much like the quantum world. As we gaze upon a night sky filled with stars, we are reminded of the infinite possibilities that lie within the smallest particles. Each star, a beacon of light, represents the potential for discovery and the promise of new knowledge. Our voyage will be a thrilling blend of scientific facts, amazing visuals, historical context, and exciting discoveries. Picture scientists working diligently in an outdoor field lab, their faces illuminated by the glow of their instruments. They are the modern-day explorers, charting the unknown territories of the quantum realm. As a group of people observes the sunset over a tranquil lake, we are reminded of the beauty that science seeks to understand and the awe that drives our quest for knowledge. From the ancient Greeks, who first dared to imagine the atom, to the cutting edge of quantum computing, we'll traverse the vast landscapes of knowledge, unraveling the mysteries of the universe one atom at a time. Imagine walking through ancient ruins in Greece, where philosophers like Democritus first pondered the nature of matter. Fast forward to the present, where drone footage captures the bustling energy of modern cityscapes and the timeless charm of old villages. This journey through time and space highlights the evolution of our understanding, from the philosophical musings of antiquity to the technological marvels of today. Get ready to delve into the bizarre world of quantum physics, where particles behave like waves and entanglement connects objects across vast distances. Picture waves crashing on a shore, each wave a manifestation of energy and motion, much like the particles in the quantum realm. From an aerial view, a river winds through a dense forest, its path shaped by unseen forces, mirroring the unpredictable nature of quantum particles. In this world, the familiar rules of classical physics give way to a reality that is both strange and wondrous. We'll uncover the secrets behind atomic bonds, the forces that hold everything we know together. Imagine the intricate intertwining of tree branches, each connection a testament to the strength and resilience of nature. Similarly, atomic bonds are the invisible threads that hold the fabric of our reality together. As we gaze upon a mountain range with interconnected peaks, we see a metaphor for the interconnectedness of all things, bound together by the fundamental forces of the universe. And we'll explore how our evolving understanding of atoms has led to technological marvels shaping the world around us. Picture wind turbines spinning gracefully in a field, harnessing the power of the wind to generate clean energy. In a desert, solar panels gleam under the sun, converting light into electricity. These technologies, born from our understanding of atomic and quantum principles, are transforming our world. In a bustling cityscape, modern technology seamlessly integrates into daily life, a testament to human ingenuity and the power of scientific discovery. But our journey doesn't end there. Imagine a pathway leading into a dense forest, each step taking us deeper into the unknown, or a road extending into the horizon, promising new adventures and discoveries just beyond our sight. Our quest for knowledge is a never-ending journey, one that continually pushes the boundaries of what we know and what we can achieve. We'll also venture into the rapidly evolving world of artificial intelligence, a realm where human ingenuity meets computational power. Picture a robot interacting with people in a park, its movements fluid and almost lifelike. Engineers work on a drone outside, fine-tuning its capabilities. This is the frontier of AI, where machines learn, adapt, and even think in ways that were once the realm of science fiction. The fusion of AI and quantum computing holds the promise of unprecedented advancements, from solving complex problems to creating new forms of art and expression. We'll explore the profound implications of quantum computing and how it's poised to revolutionize fields from medicine to material science. Imagine drone footage of a hospital where quantum computing is being used to develop new treatments and cures. Scientists examine materials outdoors, their research driven by the potential of quantum technologies to create stronger, lighter, and more efficient materials. The impact of these advancements will be felt across every aspect of our lives, from healthcare to manufacturing and beyond. So, buckle up and get ready for an unforgettable adventure into the quantum realm. Let the exploration begin. Picture an aerial view of a roller coaster, its twists and turns a metaphor for the thrilling journey ahead. A group of friends excitedly starts a road trip, their faces filled with anticipation and joy. This is the spirit of our adventure, a journey filled with wonder, discovery, and the thrill of the unknown. Together we'll explore the quantum realm, uncovering its secrets and marveling at the beauty and complexity of the universe. Consider for a moment the sheer diversity of our world, shimmering stars scattered across the cosmos, lush rainforests teeming with life, even the intricate workings of your own hand. What is it that unites these seemingly disparate parts of our universe? The answer, my friends, lies in the enigmatic world of atoms. Atoms are the fundamental building blocks of matter, the smallest unit of an element that retains the chemical properties of that element. Imagine them as the cosmic Lego bricks from which everything we know is constructed. Just like Legos, atoms can combine in countless ways to create the staggering variety we observe in the universe. But unlike their plastic counterparts, atoms are governed by the laws of physics, specifically the captivating world of quantum mechanics. These laws dictate how atoms interact, bond, and form the molecules that make up everything from the air we breathe to the very device you're watching this on. So as we begin our exploration into the heart of matter, remember this. Within each atom lies a universe of wonder waiting to be discovered. Join me as we delve into the subatomic realm and uncover the secrets these tiny titans hold. When we gaze up at the night sky, we are not just looking at distant stars and galaxies, we are peering into the very fabric of the universe, a fabric woven from countless atoms. From the vastness of space to the microscopic world within our bodies, atoms are the common thread that connects all of existence. Each atom is a tiny universe in itself, with a nucleus at its center, surrounded by a cloud of electrons. The nucleus, composed of protons and neutrons, is incredibly dense and holds most of the atom's mass. The behavior of electrons, governed by quantum mechanics, determines how atoms interact and bond with each other. These interactions lead to the formation of molecules, which are the building blocks of all matter. The periodic table is a map of the elements, each one representing a different type of atom with unique properties. By understanding the properties of these elements, we can predict how they will interact and combine to form new substances. This knowledge has led to countless discoveries and innovations, from the development of new materials to advances in medicine and technology. Atoms are not static, they are constantly in motion, vibrating and interacting with each other. This dynamic nature of atoms is what gives rise to the properties of different materials, from the hardness of diamonds to the flexibility of rubber. The arrangement of atoms in a material determines its structure and properties. For example, the atoms in a crystal are arranged in a regular, repeating pattern, giving the crystal its unique shape and properties. Understanding the atomic structure of materials allows scientists to design new materials with specific properties for various applications. Nanotechnology, for example, involves manipulating atoms and molecules to create new materials and devices with unprecedented capabilities. This field has the potential to revolutionize industries such as medicine, electronics, and energy. The study of atoms also helps us understand the fundamental forces of nature, such as electromagnetism and gravity. These forces govern the interactions between atoms and the behavior of matter on both the macroscopic and microscopic scales. By studying atoms, we gain insights into the very nature of reality and the underlying principles that govern the universe. This knowledge not only satisfies our curiosity, but also empowers us to harness the power of nature for the benefit of humanity. From developing sustainable energy sources to creating new medical treatments, the study of atoms has far-reaching implications for our future. As we continue to explore the atomic world, we inspire future generations to push the boundaries of knowledge and innovation. The journey of discovery is never-ending, and each new finding brings us closer to understanding the mysteries of the universe. So, as we embark on this exploration of atoms, let us embrace the wonder and curiosity that drive scientific inquiry. Let us remember that within each atom lies a story waiting to be told, a secret waiting to be uncovered. And as we share this knowledge, we contribute to the collective understanding of our world and our place in the cosmos. Join me on this journey into the heart of matter, where we will uncover the secrets of atoms and the wonders they hold. Together, we will explore the building blocks of the universe and marvel at the intricate dance of atoms that creates the world around us. Let us embark on this adventure with open minds and hearts, ready to be amazed by the beauty and complexity of the atomic world. The journey into the subatomic realm awaits us, filled with discoveries that will change the way we see the universe and ourselves. So, let us take the first step together and dive into the fascinating world of atoms, where every discovery is a step closer to understanding the grand tapestry of existence. With each revelation, we illuminate the path forward, guided by the light of knowledge and the spirit of exploration. Let us navigate this journey with curiosity and wonder, always seeking to uncover the hidden truths of the atomic world. Together, we will delve into the subatomic realm and uncover the secrets these tiny titans hold. Our quest to understand the atom takes us back in time, to ancient Greece, where philosophers contemplated the nature of reality. These early thinkers were not scientists in the modern sense, but their curiosity and desire to explain the world around them laid the groundwork for future scientific inquiry. They pondered questions that still intrigue us today. What is the universe made of? What is the nature of existence? How do the fundamental components of matter interact to form the world we see? Imagine a time without microscopes, particle accelerators, or even the concept of an element. The tools and technologies we take for granted today were unimaginable to the ancient Greeks. They relied on observation and philosophical reasoning to explore the mysteries of the natural world. In bustling markets and serene landscapes, they debated and discussed their ideas, seeking to understand the underlying principles of nature. It was in this world, around 400 BC, that Democritus, a philosopher with a penchant for deep thought, first proposed the idea of atoms. Democritus was a student of Leucippus, and together they developed a theory that would challenge the prevailing views of their time. They suggested that everything in the universe was composed of tiny, indivisible particles called atomos. This radical idea was a departure from the more widely accepted belief that matter was continuous and could be divided infinitely. Democritus, along with his mentor Leucippus, dared to imagine that all matter was composed of tiny indivisible particles they called atomos, meaning uncuttable or indivisible. They envisioned a universe where these atoms moved through a void, colliding and combining to form the diverse materials and objects we observe. This idea was revolutionary, as it suggested that the complexity of the natural world could be explained by the interactions of simple fundamental particles. They envisioned these atoms as eternal, unchanging, and existing in a void, constantly in motion and colliding with each other. This dynamic view of matter was in stark contrast to the static, unchanging elements proposed by other philosophers. Democritus and Leucippus believed that the properties of materials were determined by the shapes, sizes, and arrangements of their constituent atoms. For example, they thought that the hardness of a material was due to the presence of tightly packed, solid atoms, while the fluidity of a liquid was the result of loosely connected, smooth atoms. Now, keep in mind, Democritus's ideas were philosophical musings, not based on experimental evidence. The ancient Greeks did not have the means to test their theories through experimentation, so their ideas remained speculative. Despite this, the atomic theory of Democritus and Leucippus was a remarkable intellectual achievement. It demonstrated the power of human imagination and reasoning to explore the fundamental nature of reality, even in the absence of empirical data. In fact, his atomic theory was met with skepticism by many, including the influential philosopher Aristotle, who favored the idea of matter being composed of four elements: earth, air, fire, and water. Aristotle's views were more in line with the prevailing beliefs of the time, and his ideas would dominate scientific thought for centuries. He argued that the properties of materials could be explained by the interactions of these four elements, each of which had its own unique qualities. This elemental theory was more intuitive and easier to understand than the abstract concept of indivisible atoms. Despite the lack of empirical support, Democritus's concept of atoms, though rudimentary, planted the seeds for a scientific revolution that would blossom centuries later. His ideas were preserved and transmitted through the works of later philosophers and scholars who recognized the significance of his contributions. The atomic theory would eventually be revived and refined by scientists in the modern era, leading to groundbreaking discoveries in physics and chemistry. His ideas would remain dormant for nearly 2 millennia before being resurrected and reshaped by the scientific minds of the 19th century. The development of new technologies and experimental techniques allowed scientists to test and expand upon the theories of Democritus and Leucippus. The discovery of subatomic particles, the formulation of quantum mechanics, and the development of the periodic table all owe a debt to the early atomic theory. Today, our understanding of the atom continues to evolve, but the foundational ideas of Democritus and Leucippus remain a testament to the enduring power of human curiosity and imagination. We've established that atoms are the fundamental building blocks of matter, but like any good cosmic mystery, there's always more to uncover. Atoms themselves are made up of even smaller particles called subatomic particles. These particles reside in the quantum realm, a strange and counterintuitive world where the rules of classical physics break down. Think of it this way. If an atom were the size of a football stadium, the nucleus, where the protons and neutrons reside, would be like a single marble at the center of the field. And the electrons, they'd be like tiny, almost massless blurs whizzing around the stadium at incredibly high speeds. These subatomic particles are not just miniature versions of their larger counterparts. They possess unique properties and behaviors that govern the interactions of atoms and ultimately dictate the nature of the universe itself. Join me as we venture further into the subatomic realm, exploring the peculiar characteristics of protons, neutrons, and electrons, and unraveling the secrets they hold about the universe's fundamental forces. Atoms, despite their nature as the fundamental building blocks of matter, are surprisingly sociable entities. They are the smallest units of elements, each with its own unique properties, yet they rarely exist alone. Instead, they prefer to interact and connect with other atoms, forming bonds that create the vast array of substances we encounter in our daily lives. This sociability is not just a random occurrence, it is a fundamental aspect of their nature. Driven by the laws of physics and chemistry, they rarely exist in isolation, preferring instead to forge bonds with other atoms, creating the molecules that make up our world. These interactions are akin to the relationships we see in nature, where organisms work together to create a balanced ecosystem. Just as bees pollinate flowers and birds build nests, atoms come together to form the molecules that are essential for life. These atomic bonds are not merely abstract concepts. They are the very essence of chemistry, dictating the properties of substances and their ability to react with one another. Imagine the bonds as the glue that holds the world together, determining whether a substance is solid, liquid, or gas, and how it interacts with other substances. These bonds are responsible for the diversity of materials we see around us, from the hardness of diamonds to the flexibility of rubber. From the air we breathe to the water we drink, atomic bonds are at play. The oxygen molecules that fill our lungs and the water molecules that hydrate our bodies are all held together by these invisible forces. Without these bonds, the very air we depend on for survival would not exist in its current form. From the proteins that build our bodies to the silicon that powers our computers, atomic bonds are the foundation of our technological advancements. Proteins, which are essential for the structure and function of our cells, are made up of long chains of amino acids held together by peptide bonds. Similarly, the silicon chips that drive our computers and smartphones are created through the precise arrangement of silicon atoms. Atomic bonds are the invisible architects of our material reality. They design and construct the world we live in, from the smallest particles to the largest structures. Whether it's the steel beams of a skyscraper or the delicate petals of a flower, atomic bonds are at the heart of it all, shaping the physical world in ways we often take for granted. But what drives these atoms to seek companionship? The answer lies in their quest for stability. Atoms are constantly seeking a state of minimum energy where their outermost electron shells are filled. This drive for stability is a fundamental principle of nature, influencing the behavior of atoms and the formation of bonds. The answer lies in their quest for stability, a state of minimum energy where their outermost electron shells are filled. This quest is guided by the octet rule, which states that atoms are most stable when they have 8 electrons in their outer shell. This rule explains why atoms are so eager to share, donate, or even steal electrons from one another, forming the basis of chemical bonding. This driving force, known as the octet rule, compels atoms to share, donate, or even steal electrons from one another, forming the basis of chemical bonding. This behavior can be likened to the way people interact in social settings, sharing resources and working together to achieve common goals. Just as friends share a meal or children share toys, atoms share electrons to achieve stability. Join me as we delve into the fascinating world of atomic bonding, exploring the different types of bonds that atoms form. We will uncover the secrets behind ionic bonds, where atoms transfer electrons to achieve stability, and covalent bonds, where atoms share electrons to create strong connections. We will also explore metallic bonds, which give metals their unique properties, and hydrogen bonds, which play a crucial role in the structure of water and biological molecules. Exploring the different types of bonds that atoms form, we will see how these interactions give rise to the incredible diversity of matter in our universe. From the vibrant colors of flowers to the intricate structures of coral reefs, atomic bonds are responsible for the beauty and complexity of the natural world. Each type of bond brings its own unique characteristics, contributing to the rich tapestry of life and matter. and discovering how these microscopic interactions give rise to the incredible diversity of matter in our universe. The night sky full of stars, the vibrant fields of wildflowers, and the rainbows after a storm are all manifestations of atomic bonds at work. These bonds create the patterns and structures that make our world so fascinating and beautiful. So let's embark on this journey together, uncovering the mysteries of atomic bonds and appreciating the wonders they create. We've explored the atom, its constituent subatomic particles, and the bonds that unite them. But to truly grasp the workings of the universe at its most fundamental level, we must venture into the realm of quantum physics. Quantum physics, you see, is not merely a refinement of classical physics. It's a radical departure, a paradigm shift in our understanding of reality. In the quantum realm, the deterministic laws of classical physics give way to probabilities, uncertainties, and a profound interconnectedness that defies our everyday intuitions. Imagine a world where energy, like matter, exists in discrete packets, where particles can be in multiple states at once, and where the act of observation can alter the very nature of what is being observed. This is the strange and wondrous world of quantum physics. We'll embark on a journey to explore the fundamental principles of this mind-bending field, from wave-particle duality to quantum entanglement, from the Heisenberg uncertainty principle to quantum superposition. Fasten your seatbelts, for the quantum realm is not for the faint of heart, but it holds the key to unlocking the universe's deepest secrets. For centuries, the nature of light itself was a mystery. Some scientists, like Isaac Newton, believed it was made of tiny particles, corpuscles, he called them. Others, like Christian Huygens, argued for a wave-like nature. Turns out they were both right in a way. Our intuition tells us things should be one way or another. A bird is a bird, a plane is a plane. But the universe, especially at the quantum level, doesn't much care for our intuition. Light, as it turns out, can act like both a wave and a particle. This experiment, known as the double-slit experiment, shows light behaving like waves, creating these interference patterns. But light can also knock electrons off a metal surface, something only particles can do. This is the photoelectric effect, and it earned Einstein a Nobel Prize. So which is it then, wave or particle? Well, the answer is both and neither. This is the heart of wave-particle duality. It's not that light switches between the two, but rather it exists as both, showing us different faces depending on how we look at it. We've journeyed deep into the heart of the atom, where particles can be waves, and certainty gives way to probability. But the quantum world has even stranger phenomena in store, phenomena that challenge our very notion of cause and effect, of locality itself. I'm talking, of course, about quantum entanglement. Imagine two particles, born from the same event, intimately linked in a way no two objects in the classical world can ever be. When you measure the state of one, the other, even if separated by vast distances, instantly knows and assumes the opposite state. This isn't just a theoretical curiosity, it's been experimentally verified time and again. It's as if these particles are two coins flipped together, always landing on opposite sides, no matter how far apart they are. Albert Einstein, as brilliant as he was, found this spooky action at a distance deeply unsettling. He believed there had to be some hidden variable, some unknown factor we weren't accounting for. But as we'll see, the universe had other plans. Our journey into the heart of matter has taken us from the familiar macroscopic world to the bizarre and counterintuitive realm of the quantum. But this journey isn't just about satisfying our curiosity, it's about harnessing the power of the atom to shape our world. For centuries we were like chefs tossing ingredients together without understanding the underlying chemistry. But with the advent of atomic theory, we gained a recipe book for the universe. allowing us to manipulate matter at its most fundamental level. This newfound knowledge sparked a technological revolution, leading to innovations that have transformed our lives in countless ways, from the smartphones in our pockets to the medical imaging devices that peer inside our bodies. The fingerprints of atomic theory are everywhere. Let's take a journey through the landscape of modern technology and uncover the profound ways in which our understanding of atoms has shaped the world around us. We've spent the last few chapters exploring the universe within, the astonishing world of atoms and the mind-bending rules of quantum mechanics. These tiny particles and their strange behaviors have given us a glimpse into the fundamental building blocks of reality. But now let's shift our focus from the microscopic to the macroscopic, from the physical to the intellectual. Now, let's turn our attention to a different kind of universe, one we're building here on Earth. The universe of intelligence. This universe isn't made of stars and galaxies, but of data and algorithms, of neural networks and machine learning models. It's a universe that is expanding at an unprecedented rate, driven by our insatiable curiosity and relentless innovation. But what is intelligence exactly? Is it the ability to solve complex mathematical problems or the capacity to create beautiful works of art? Is it the power to understand and predict the behavior of others, or the skill to navigate the world with grace and precision? For centuries, philosophers have pondered this question, debating the nature of thought, consciousness, and the very essence of being. From Aristotle to Descartes, from Kant to Nietzsche, the greatest minds in history have wrestled with the mysteries of the mind. They have asked whether intelligence is a purely human trait, or whether it can be found in other forms of life or even in the machines we create. Today, we find ourselves on the cusp of a new era, where we're no longer simply pondering intelligence, but actively trying to create it. This is the age of artificial intelligence, or AI, where the lines between human and machine are becoming increasingly blurred. In this new era, we are not just observers of intelligence, but its architects and engineers. This is the audacious goal of artificial intelligence, or AI, to build machines capable of performing tasks that typically require human-level intelligence. These tasks range from the mundane to the extraordinary, from recognizing faces in a crowd to diagnosing diseases, from driving cars to composing symphonies. The potential applications of AI are as vast and varied as the human imagination itself. From self-driving cars navigating complex traffic, where split-second decisions can mean the difference between life and death, to virtual assistants that can understand and respond to our spoken commands, AI is transforming the way we live and work. These technologies are not just tools but partners in our daily lives, helping us to be more efficient, more productive, and more creative. To algorithms composing music that rivals the works of the masters, AI is pushing the boundaries of creativity and expression. These algorithms can analyze vast amounts of musical data, identifying patterns and structures that even the most talented human composers might miss. They can generate new compositions that are both original and deeply moving, challenging our notions of what it means to be an artist. AI is rapidly pushing the boundaries of what machines can do. From healthcare to finance, from education to entertainment, AI is revolutionizing every aspect of our society. It is enabling us to solve problems that were once thought to be intractable, to make discoveries that were once beyond our reach, and to create experiences that were once unimaginable. But the quest for AI is about more than just building impressive machines. It's about understanding our own intelligence, about unraveling the mysteries of how our brains learn, adapt, and solve problems. By studying AI, we are not just creating new technologies, but gaining new insights into the nature of intelligence itself. It's about understanding our own intelligence, about unraveling the mysteries of how our brains learn, adapt, and solve problems. By studying AI, we're essentially holding a mirror up to ourselves, gaining a deeper understanding of what it means to be human. We are learning about the strengths and limitations of our own minds and discovering new ways to enhance and augment our cognitive abilities. By studying AI, we're essentially holding a mirror up to ourselves, gaining a deeper understanding of what it means to be human. We are exploring the frontiers of our own consciousness, and in the process, we are redefining what it means to be intelligent. This journey is not just about building smarter machines, but about becoming smarter ourselves, about unlocking the full potential of the human mind. For decades, our computers have relied on the principles of classical physics, processing information as bits, which can be either a 0 or a 1. This binary system has served us well, enabling us to build incredible machines that have transformed our world. But even with the remarkable advancements in classical computing, there are limits to what these machines can achieve. Certain problems, particularly those involving complex systems, with a vast number of possible states, remain intractable for even the most powerful supercomputers. Think about the intricate folding of proteins, the behavior of financial markets, or the search for new materials with specific properties. These challenges involve grappling with an astronomical number of possibilities, quickly overwhelming the capabilities of classical computers. This is where the strange and counterintuitive world of quantum mechanics offers a tantalizing possibility, a fundamentally different way of processing information. We've spent much of our journey exploring the universe on a microscopic scale, delving into the heart of atoms and the strange laws that govern their behavior. But now, let's zoom out, way out, and contemplate the grand cosmic tapestry woven from these fundamental building blocks. For it is from these humble atoms, forged in the fiery hearts of stars, that everything we know and cherish is made. The air we breathe, the water we drink, the very ground we stand on, all trace their origins back to the nuclear furnaces scattered across the vast expanse of space. Billions of years ago, our universe was a vastly different place. A hot, dense soup of elementary particles expanding and cooling in the aftermath of the Big Bang. As the universe expanded and cooled, these particles began to combine, forming the first atoms, primarily hydrogen and helium, the simplest and most abundant elements in the cosmos. These early atoms, drawn together by gravity, coalesced into massive clouds of gas which eventually collapsed under their own weight, igniting the first stars and illuminating the darkness of the early universe. We've spent this time together exploring the universe within, the atom, and the universe without, the cosmos. From the tiniest particles that make up our world to the vast expanses of space that stretch beyond our imagination, science has always been about pushing the boundaries of what we know and understand. The journey of discovery is never-ending, and each new finding opens up even more questions and mysteries to solve. It's a beautiful, intricate dance of curiosity and knowledge, one that has driven humanity forward for centuries. But what happens when we bring these two seemingly disparate worlds together? What happens when the micro meets the macro, and the boundaries between the very small and the very large begin to blur? This is where the magic of interdisciplinary science comes into play. By combining insights from different fields, we can create a more comprehensive understanding of the universe. It's like putting together pieces of a puzzle where each piece represents a different aspect of reality. When we bring them together, we get a clearer picture of the whole. What happens when we use the power of artificial intelligence to unlock the secrets of the quantum realm? The quantum world is a place of strange and fascinating phenomena where particles can exist in multiple states at once and can be entangled across vast distances. It's a realm that defies our everyday understanding of reality, and yet it holds the key to many of the mysteries of the universe. By harnessing the power of AI, we can delve deeper into this enigmatic world, uncovering new insights and pushing the boundaries of what we know. For centuries, science has relied on the brilliant minds of humans to painstakingly unravel the mysteries of the universe. From the early astronomers who mapped the stars to the physicists who developed the theories of relativity and quantum mechanics, human ingenuity and perseverance have been at the heart of scientific progress. These pioneers have laid the groundwork for the incredible advancements we see today, and their legacy continues to inspire new generations of scientists and researchers. We've built telescopes to peer into the distant cosmos, capturing the light from stars and galaxies that are millions or even billions of light years away. These incredible instruments have allowed us to see the universe in ways that were once unimaginable, revealing the beauty and complexity of the cosmos. From the majestic rings of Saturn to the swirling clouds of distant nebulae, telescopes have opened our eyes to the wonders of the universe. Microscopes to probe the intricacies of life, allowing us to see the tiny building blocks that make up all living things. With these powerful tools, we've been able to explore the hidden world of cells and microorganisms, uncovering the secrets of life at the smallest scales. From the structure of DNA to the complex interactions between cells, microscopes have given us a window into the fundamental processes that drive life, and particle accelerators to smash atoms together in the hopes of understanding their fundamental building blocks. These massive machines have allowed us to probe the very fabric of reality, revealing the particles and forces that make up the universe. By recreating the conditions of the early universe, particle accelerators have helped us to understand the origins of matter and the fundamental laws of physics. But now a new player has emerged on the scientific stage: artificial intelligence. AI is revolutionizing the way we approach scientific research, offering new tools and techniques that can enhance our understanding of the world. With its ability to process vast amounts of data and identify patterns that would be impossible for humans to detect, AI is opening up new frontiers in science. It's like having a supercharged assistant that can help us to make sense of the complex and often overwhelming data that modern science generates. Imagine a world where machines can not only analyze data with lightning speed, but also learn, adapt, and even make their own discoveries. This is the promise of AI, a technology that has the potential to transform every aspect of our lives. From healthcare to climate science, AI is already making a difference, helping us to tackle some of the biggest challenges facing humanity. By augmenting our own abilities, AI is enabling us to achieve things that were once thought impossible. This isn't science fiction, my friends. This is the future of scientific exploration. AI is not just a tool for analyzing data, it's a partner in discovery, helping us to push the boundaries of what we know and understand. With its ability to learn and adapt, AI is opening up new possibilities for scientific research, allowing us to explore the universe in ways that were once unimaginable. It's an exciting time to be a scientist as we stand on the brink of a new era of discovery. This is the future of scientific exploration. As we look to the horizon, we can see a world where AI and human ingenuity work hand in hand to unlock the mysteries of the universe. It's a future where the boundaries between disciplines blur and where the insights from one field can inform and enhance our understanding of another. By embracing the power of AI, we can create a more interconnected and comprehensive view of the world, one that allows us to tackle the biggest questions and challenges of our time. These AI-powered systems are already making waves in fields like astronomy, where they're being used to sift through mountains of data from telescopes. With their ability to process vast amounts of information quickly and accurately, AI systems are helping astronomers to identify distant galaxies, track the movements of celestial objects, and even search for potential signs of extraterrestrial life. By automating many of the time-consuming tasks that were once done by hand, AI is freeing up scientists to focus on the big questions and make new discoveries. Where they're being used to sift through mountains of data from telescopes, identifying distant galaxies, and even potential signs of extraterrestrial life. The sheer volume of data generated by modern telescopes is staggering, and it's simply not possible for humans to analyze it all on their own. AI systems can process this data at incredible speeds, identifying patterns and anomalies that might otherwise go unnoticed. This is helping astronomers to make new discoveries and gain a deeper understanding of the universe, identifying distant galaxies and even potential signs of extraterrestrial life. In the search for extraterrestrial life, AI is playing a crucial role. By analyzing data from telescopes and other instruments, AI systems can identify potential signs of life, such as unusual patterns of light or chemical signatures. This is helping scientists to narrow down the search and focus their efforts on the most promising targets. It's an exciting time for the field of astrobiology, as AI opens up new possibilities for the search for life beyond Earth. In medicine, AI is helping doctors diagnose diseases earlier and with greater accuracy, paving the way for personalized treatments tailored to each patient's unique genetic makeup. By analyzing medical data, AI systems can identify patterns and correlations that might be missed by human doctors, leading to earlier and more accurate diagnoses. This is particularly important for diseases like cancer, where early detection can make a significant difference in outcomes. AI is also helping to develop personalized treatment plans, taking into account a patient's genetic makeup, lifestyle, and other factors to create the most effective therapies, paving the way for personalized treatments tailored to each patient's unique genetic makeup. The field of personalized medicine is one of the most exciting areas of medical research, and AI is playing a key role in its development. By analyzing genetic data, AI systems can identify the specific mutations and variations that contribute to a patient's disease, allowing doctors to develop targeted treatments that are tailored to the individual's unique genetic profile. This is leading to more effective therapies and better outcomes for patients, as treatments can be customized to address the specific underlying causes of their condition. Section 2. Decoding the Book of Life. As we continue to explore the potential of AI in science, one of the most exciting areas of research is the field of genomics. By analyzing the vast amounts of genetic data that are now available, AI systems are helping scientists to decode the Book of Life, uncovering the secrets of our DNA and understanding how it shapes who we are. This is leading to new insights into the genetic basis of diseases, as well as new opportunities for developing targeted therapies and personalized treatments. The future of science is bright, and AI is helping to light the way. We've journeyed deep into the heart of matter, exploring the bizarre and counterintuitive world of quantum mechanics. We've seen how particles can exist in multiple states at once, how they can be entangled across vast distances, and how their behavior challenges our very notions of cause and effect. But our exploration of the quantum realm is far from over. In fact, it's just beginning. Like explorers charting a new continent, we stand on the precipice of a vast uncharted territory, teeming with mysteries waiting to be unraveled. Imagine a future where we can harness the power of quantum entanglement to build unhackable communication networks, where quantum computers can solve problems in seconds that would take classical computers billions of years, and where we can manipulate the very fabric of space-time. This is the tantalizing promise of the quantum future. We've journeyed deep into the quantum realm, exploring the bizarre and beautiful world of atoms and their strange behavior. But how do we grasp these concepts, these particles smaller than a billionth of a meter, in a tangible way? Well, fear not, fellow explorers. Just as astronomers build models of the cosmos, we can use everyday objects to represent the invisible architecture of matter. Imagine a simple grape. Now picture that grape representing the nucleus of an atom, housing the protons and neutrons. Zooming out, imagine tiny fruit flies buzzing around the grape, tracing out vast, invisible paths. These flies represent the electrons, whizzing around the nucleus in their fuzzy, probabilistic dance. Of course, this is a simplified model, but it helps visualize the immense emptiness within an atom. Remember, if the grape were the size of a football stadium, the nucleus would be like a tiny marble at the center, and the electrons, mere specks of dust, would be the only inhabitants of that vast atomic arena. Now let's dive into some of the most common questions about the fascinating world of atoms and their quirky inhabitants. One question that often comes up is, if atoms are mostly empty space, why doesn't matter just pass through itself? This is where the strange rules of the quantum world come into play. Electrons, those tiny specks orbiting the nucleus, are governed by the Pauli exclusion principle. This principle states that no two electrons in an atom can occupy the same quantum state simultaneously. Think of it like a crowded dance floor. Each electron needs its own space to move around. When atoms get too close, their electron clouds repel each other, preventing them from collapsing into each other. It's this electromagnetic repulsion between electrons that gives solidity to matter, even though it's mostly empty space. It's a cosmic dance of repulsion and attraction, orchestrated by the laws of quantum mechanics. As we conclude our journey into the infinitesimal world of atoms and the vast possibilities of quantum physics and artificial intelligence, I urge you to remember one thing. Curiosity is the engine of discovery. Never stop questioning, never stop exploring. From the smallest particles to the grandest cosmic structures, the universe is filled with wonder waiting to be unveiled. The more we learn, the more we realize how much more there is to know. For those eager to delve deeper into these fascinating subjects, I encourage you to explore the vast resources available online and in libraries. Seek out documentaries, read books, engage in discussions, and never stop questioning the world around you. Remember, the universe is not a static picture, but a dynamic, ever-evolving story. And you, my fellow explorers, have a front row seat to the greatest show in the cosmos. So keep exploring, keep questioning, and never lose your sense of wonder.